This is my light project, where we were tasked to design a torch or a light for any use or application that we could think of. For this unit, we were tasked to create a light within 30 hours. This was involved the 3D printing of this, product design, and planning the times of all the parts of the project. Within this PowerPoint is a show of how I went about it and my results. I chose to design a torch with a Kitronic 5V LED, RS Pro battery holder, 3AA, and a Kitronic switch, as these components perfectly fit the design and allowed it to be successful. In addition, I made the product through 3D printing with PETG, as it was the most cost-effective and long-lasting material, as well as allowing it to be recyclable and have little effect on the environment. Here is my research overview. Before I began the design phase of my project, I began by researching current lights on the market to get a grasp of the competition my product would face, and what successful lights would look like. Along with researching current products, I researched joining methods like gluing, self-threading screws and tapping. I also researched 3D printable materials like PETG, ABS and PLA, and different circuit boards and electrical components for my torch. Throughout the research, I decided which material to use, which was PLA, which electrical components to use, such as the battery pack, switch and the LED circuit, and how I would join parts together, which was glue. This assisted my design by giving me examples of existing products on the market and allowed me to look at many parts materials I could use, and then judge them based on how they would meet my PDS. Here are the 4 concepts I created using different materials, electrical components and ideas. In concept 1, you can see the belt clip, an LED circuit board from Kitronic, an on-off switch, also from Kitronic. You can see it's made out of PETG and has a grippy node texture on the side, so it's a twist-offable bottom for inserting a battery pack. In concept 2, you can see the belt clip, which is in every design. The same LED circuit used in concept 1, a grippy texture from knurling on the side of it, a battery pack, which has a removable cover and an on-off switch, also glued onto the side of the torch. Concept 3 contains the same belt clip, a different LED panel also from Kitronic, and the same battery pack used in Concept 2, as well as a similar switch. In Concept 4, you can see the same LED panel from Concept 3, a belt clip like all the other designs, it also being made of PETG and 3D printed, and also a node texture for grip, as well as the on-off switch. Next, to gain an idea of which one of my designs was most suitable, I carried out a feasibility study. This involved SWOT analysis and a weighted design matrix to gather which one was the best. The weighted design matrix allowed me to judge certain aspects of my design on how suitable it was to the requirements of it. This resulted in me coming out with Concept 2 as a leading contender and the design I would take forward. Next, I made a Gantt chart. This was used to manage and allocate time spent throughout the project. I used the MS Project tool to create the Gantt chart, and then I used it to keep track of my progress throughout the entire project. Here's part of it, another part, and here is the final part. Next, I created a risk register before I began the design phase. I created a risk register covering all potential risks facing me throughout the course of my project. I use this risk register to note the risks that are present and how to plan and mitigate these risks. You can see it in PDS to detail and outline all the targets my final design would meet to be successful. This gave me an outline of all the parts I'd need to meet, and these points were based off my concept designs and my feasibility study. You can see all these points here, such as my product would have to be able to illuminate a workspace. The product would have to be below 1 kilogram in weight. The product must be able to fit in your hand and be gripped around easily. The product must have a replaceable power source so it has no charging times. The product must match an EDF colour scheme as it will be using EDF workspaces. The product must be made of material which is aesthetically pleasing finish, such as the glossy finish of PETG. The product must have a cylindrical shape for easy fit within the hand. The product must have a clip for hands-free carrying. The product must have a texture that adds increased grip in a wet or slippery condition, such as the knurling. The product must have no sharp edges to minimise risk, so all sides must be chamfered. The product must be made of a material suitable for 3D printing, such as PETG. My product must be tough, wear-resistant material like PETG, so its environmental effects will be minimised by its long life and its recyclability. The product must cost under £200 to be considered a success. The product must be left to cool after 3D printing to ensure no burns are caused. The product must securely house the battery pack in an LED panel and be waterproof. The product should be assembled using glue and components of the product. The product must be recyclable at the end of its life, and the product must be made of PETG as it's recyclable. Next, I had to use design iteration during my project. During the project, I had to redesign and alter parts of my product, such as the battery pack I had to change to a better suited battery pack for my product, along with the switch I had to change. These redesigns helped strengthen how successful my product is and allowed it to succeed and meet the PDS. Iteration I did on my design concept too, compared to my final design, included adding a lid to make it waterproof, changing the electrical components like the battery pack and switch, and making it hollow, reducing 3D printing costs, and allowing all the wiring to be internal, making it watertight. Next is my midway Gantt chart. As you can see, I have ticked off parts of it that I had completed, such as the risk register, the technical specification, and how I began my design solutions. Here you can see where it's been ticked off. Here is my final design. As you can see, an exploded view and an assembled view of it. After using the PDS and the SWOT analysis to generate the best design to take forward, I used my prior sketches in SolidWorks to make my final SolidWorks model of the part. It's made of PETG and uses a Kitronic 5V LED and a Kitronic switch and the battery pack, which are wired and soldered together and protected by all wires being internal and the LED being under a transparent lid. The next phase was testing. This involved checking that all the costs were below £200, which I identified due to the cost of 3D printing would be £58.69, and the cost of all the electrical components together would be less than £8. This would make the cost of manufacturing my product £68, which makes a £200 budget and is a success. The product is made of PETG, so it's recyclable and 3D printable, as stated in the basis of 3D printing ebook. The design is ergonomic, as it is a nailed texture for added grip and is round to fit within a hand. The design is able to illuminate a workspace as it emits 4800 MCD, as stated on the Kitronic website, and includes a clip to hang off a belt. In conclusion, testing has proved my design meets the PDS and can be considered a success. Issues faced during my project that caused me to improvise and adapt, such as redesigns, due to the battery and the switch being unfit for the design, so this had to be changed. Another issue faced was internet issues, which impacted my efficiency while not causing me to miss deadlines. I had to utilise a laptop at points due to the PC being slow. Here is my final Gantt chart, which details me completing all of the different steps that I had planned out in the manufacture of the Gantt chart. Thank you for your time.